Okay. So in last class, I discussed with you that how the specific heat was deviated from the experimental data. Yes.
Yes, sir.
And now there is a concept of what we call is degree of freedom. Degree of freedom. So if you see the idea of average energy with our model, what we found is that the average energy is equal to 3 by 2 kBT, right? And using this, if I calculated the specific heat CV, that was equal to 3 R, correct? 3 by
Yes,
2,
sir.
3 by 2 R. Differentiate this with respect to temperature. You will get 3 by 2 kb and then multiply it by Avogadro number. You will get 3 by 2 R. And then you calculated Cp, which was 3 by 2 R plus R, which is 5 by 2 R. And then you calculated gamma with your this model. Gamma was Cp by Cv, which is equal to how much? 5,
1.6.
5 by 3, which is 1.66. So this is prediction of our theoretical model, and it goes well with monoatomic gas. Monoatomic gas. See your table that I made. It goes well with monoatomic gas. For example, what examples I have given you? Argon and
Helium.
argon and helium. So now what is happening? Actually, the formula that we have derived, that average energy is equal to 3 by 2 kBT. It is not good for all type of molecules, but it is only good for monoatomic gas, which is, this formula should be like this: F by 2 kBT, and F is equal to 3 is for monoatomic gas. F is equal to 3 is for monoatomic gas, and this quantity F is called degree of freedom. So because degree of freedom is different for different gases, so that's why this formula will modify. And when this formula modifies, then Cp and Cv and their ratio, which is called adiabatic exponent, these all things will modify. So we have to now find out what is this quantity that is called degree of freedom. इसको कैसे calculate करते हैं, इसका क्या concept है? We have to consider all those concepts. Okay? Right?
Yes, sir.
समझ आ रहा है भाई सबको?
Yes,
This is okay ना? So now
Yes, sir.
actually the problem is that in a gas we are considering the energy of the gas. So if that gas molecule is a point sized molecule, अगर वो gas molecule point sized molecule है, if it is a point sized molecule, then it is only having translational energy. But if it is, say, diatomic molecule or triatomic molecule or polyatomic molecule, it may have rotation, vibration, so more energy will be included. Yes? More energy terms will be included. So we have to understand that because we only considered, please check the points that I gave you during the derivation of our model, we consider our gas molecule to be a point sized. याद है? We
Yes, sir.
considered it as a point mass in our model. So because we considered as a point mass, so that's why only translational energy were present. Translational energy were present. Translational kinetic energy was present there. And because three modes were present, अभी मैं explain करूंगा. One corresponding to x-axis, another corresponding to y-axis, another corresponding to z-axis. So three modes were present. So because of that, 3 into half kBT is the energy in every mode. Every mode carries half kBT energy. So at least this is true for ideal gas. So this law is called equipartition law. Equipartition. Law of equipartition. That means energy half kBT goes in every mode. So because three modes were available, corresponding to x, corresponding to y, and corresponding to z. So that's why 3 into half kBT, we got 3 by 2 kBT. And this 3 is called degree of freedom. So let me define degree of freedom. So the degree of freedom is defined in two ways. First one is just considering the geometric aspect. And this only goes well up to room temperature. At higher temperature, this geometrical aspect cannot be considered for degree of freedom. So geometric aspect is that the degree of freedom F is equal to 3n minus k, where n is number of atoms and k is number of constraints. N is number of atoms and k is number of constraints. So like if you have only one atom like this, so F is equal to 3 into 1 and minus no constraint. Constraint means restrictions. And if you have, say, 2, this is diatomic. So F is 3 into 2 minus 1 because there is one constraint equation. So this geometric aspect actually is number of independent coordinates required to number of independent coordinates required to define a system. Okay, for example, if it is only monoatomic gas, So 3 coordinates are required. And if it is diatomic gas, then 3 into 2 minus 1.
5.
So that is equal to 5. And this all is only good up to room temperature. If there are, say, this is the number of atoms, a triangular shape, then F is equal to 3 into 3 minus 3, because there are 3 constrained equations. Constrained equation means, like, if suppose this is the coordinate and you have a diatomic molecule, so 3 coordinates are required to give the address to the first molecule. 3 coordinates are required to give the address to second molecule. So 3, 3, 6. But because one distance formula will relate them, so that is called the constrained equation. So here the distance formula is the constraint equation. Distance formula is constrained equation. Okay.
Yes, sir.
So this will be subtracted from this. So this will become 3. Is that okay?
Yes, sir.
बताओ भाई.
Yes, sir.
So this is the first definition of degree of freedom, which is given in terms of number of coordinates. So this is clear, absolutely clear.
Yes, sir.
Okay. Now the second definition is which is good for even higher temperatures, when all type of energy modes are involved. So what we call energy mode is, like, suppose you are at very low temperatures, so only translational and rotational modes are excited. That means molecule can move or molecule can rotate. And if you increase the temperature further, if there is a possibility of vibrations between the atoms, that will start. Okay, so that is called vibrational mode. So B I will define as first was based on geometry or based on number of coordinates, and second one is based on energy, based on energy. Okay, so this is the definition is like this: total number of independent square terms, squared terms present in the expression present in the expression of energy. Total number of independent square terms present in the expression of energy is called degree of freedom. Total number of independent square terms present in the expression of energy is called degree of freedom. So for example, if I take just monoatomic gas, then what will be its energy? It will be only translational, that is half m x dot square plus half m y dot square plus half m z dot square. Okay, so how many terms are there? First square term, second square term, third square term. So how many terms are there? 3 square terms are there. 3 square terms are there. So this is called degree of freedom. Please see this. Is this okay? Okay.
Yes, sir.
Now
Yes, sir.
let us take the diatomic molecule. Let us take the diatomic molecule. If I consider a diatomic molecule, then you will have energy is equal to, so translation energy is present obviously, half m, so इसके center of mass की translational energy लिख देंगे. Okay, so x dot square plus y dot square plus z dot square. So 3 translational terms will be there,
Yes, sir.
and if I consider the rotational terms, so it will be, suppose this is the x-axis, so rotational terms will be half I y omega square plus half I z omega square. Yes, and because of this axis, there will be no moment of inertia about this axis. So third contribution towards x will become 0. Because what is moment of inertia? Suppose this is the axis and this is the mass. This is r. So we define moment of inertia as mr square. We define moment of inertia as mr square. So that means यहाँ पे, because the mass lies on the axis itself, so contribution of moment of inertia will be not present. So how many square terms are there? Now the degree of freedom will become 5. If you increase the temperature further, then what will happen? The vibrational terms will also be included. So its degree of freedom will increase. That I will discuss in a short time. So if temperature is increased, then vibrational mode will be activated, and DOB will enhance. ये भी समझ आ गया?
Yes, sir. Yes, sir.
So I should just define the degree of freedom in a general way so that हम किसी भी molecule का, if all vibrational modes are excited, we can write the degree of freedom. And if in question it is given that one vibrational mode is excited, if suppose they give in question that one vibrational mode is excited, so that corresponds to 2 degrees of freedom. If one vibrational mode is excited, that corresponds to 2 degrees of freedom. Because if vibration starts, then a potential energy term will also have to be included because there is a restoring force acting, right? There is a restoring force also acting. So if vibrational terms will come, vibrational kinetic energy, then a potential energy will also have to be included. So that's why one vibrational mode will be equal to 2 degrees of freedom. Is this okay?
Yes, sir.
So now let me give you for n atoms so that because molecules तो बड़े बड़े भी होते हैं, so we have to consider n atoms so that the general degree of freedom can be written. Okay, so just I will explain this in form of a question. So just write down the question first of all. Suppose gas is heated such that to a temperature T such that all modes of degree of freedom is excited. Okay, so find energy and specific heat. This is the question. If the gas has, it is given that the gas has adiabatic exponent is equal to gamma, and part A is gas is diatomic, part B is it is linear anatomic, and part C is it is network anatomic. Okay, these are the 3 cases that are given. So let us discuss them. So for diatomic molecule, if all modes are excited, how we will write the energy? So it will be 3 translational. So 3 into half kBT.
Yes, sir.
And 2 rotational degree of freedom. So 2 into half kBT for diatomic molecule. And 1 vibrational mode is present because the diatomic molecule can vibrate like this. 1 mode is present. So 1 mode corresponds to 2 degrees of freedom. So it will be 1 half kBT into 2. So how much we will get?
7 by 2 kBT.
7 by 2 kBT. And if I want to write the CV, it will become 7 by 2 R. Yes or no?
Yes, sir.
Now for linear, energy is equal to, for linear what it will become? Think about it. It will be 3 into half kBt, all three translational modes. And because it is a linear, so one rotational mode will be killed like it was done in diatomic. Correct?
Yes, sir.
So it will be 2 into half kBt plus
Sir, if n molecule, n atomic it is, so n minus 2 constraints will be there. So n minus 2 vibrational modes.
so vibrational will be 3n minus 5 kBt. So total how much it will become? Add करना जरा. 3n minus 5 by 2 kBt.
सर
This one is vibrational.
सर ये हाफ के बीटी नहीं होगा क्या?
कौन सा?
वाइब्रेशनल में 3n-5 इंटू हाफ के बीटी.
ये मैंने पहले ही लिखवा दिया है. आप चेक करो अपनी कॉपी में क्या लिखवाया है मैंने.
ओके सर.
क्या लिखवाया है बताओ.
सर समझ गई सर, मतलब एक के लिए दो दो डिग्री ऑफ फ्रीडम है, दो मोड है. सॉरी.
राइट. तो इसकी एनर्जी हो गई 3n minus 5 by 2 kBt. और if it is network means non collinear, not linear. So if it is not linear, then energy will be 3 into half kBt plus
3 into 3, 1 by 2 kBt.
3 into half kBt, because there is no axis for which the moment of inertia will be killed here. It is not a straight line. And plus 3n minus 5 kBt. Here 3n minus 6 kBt. Okay.
सर
Yes, sir.
सर यह वाइब्रेशनल 3n-5 की बीटी कैसे हो?
Here it is 3n minus 5 and here it
सर
is
वो
3n
मुझे
minus
समझ में
6.
नहीं है.
ये समझना नहीं है, मैं n के लिए बता दे रहा हूं, आपको याद रखना है.
ओके
भाई
सर.
समझने का मतलब ये है कि मान लो 10 एटम्स हैं तो कहां तक आप गिनते फिरोगे वाइब्रेशनल मोड्स.
ओके सर.
बस आपको ये देखना है कितने एटम है और पुट कर देना है. ओके.
ओके सर.
सो ये कितना आ जाएगा चेक करना जरा. This will come Add all of them. Yes.
3n minus 3 whole kbt.
3n minus
3 whole bracket में kbt.
तो सेम ना.
Yes, sir.
I have written same. This is this much. Now what will be there is CV. इसका CV कितना होगा? 3n minus 3 or and what will be CV here? 3n minus 5 by 2 into R. Okay. अब क्लियर है सारा?
Yes, sir.
So,
तो ये वाला है लीनियर. इसमें देखो n इज इक्वल टू 2 ले लो. 3 2 जा 6. 6 minus 5 by 2 कितना होगा? 7 by 2.
Yes, sir.
और यहाँ क्या आ रहा है?
7/2.
तो ये 2 का था तो गिन लिया. यहाँ गिनने की जरूरत नहीं है. So this question I like very much because this explains everything and this is from Erudov. So that's why I like some of the questions of Erudov very much. They are very good to clear your concepts for the exam. तो मिटा दूं इसको?
Yes, sir.
सर
हम्म.
सर इसमें जो एनर्जी निकला वही सीवी
क्या?
सर जो एनर्जी है
हम्म.
सर वॉइस इज क्लियर है सर
जो एनर्जी है वो
वही सीवी है सर
तुम इतनी बेवकूफी वाली बात करते हो ना. इससे पहले जरा सोचो, जरा दिमाग लगाओ जरा. सीवी क्या है बताओ? बताना पड़ेगा. बताओ सीवी क्या है. मैंने बताया नहीं है.
सीवी इज FR/2
है सीवी क्या है?
FR/2
ये FR/2 है सीवी. स्पेसिफिक हीट की बेसिक डेफिनेशन क्या है? हाउ इट इज डिफाइंड? del U by del T
del T
at constant volume.
यस सर
So जब तुम्हें एनर्जी मिल गई
यस सर
3n minus 3 kBT, तो एनर्जी एक मोल, ये तो एक की है, एक मॉलिक्यूल की एनर्जी है.
यस सर
एवोगैड्रो नंबर से मल्टीप्लाई कर दो kb को, kbr बन जाएगा kb इंटू Na.
यस सर
और फिर जब टेम्परेचर के रिस्पेक्ट में डेरिवेटिव करोगे तो T गायब हो जाएगा.
यस सर
ये नहीं डिस्कस हुआ है? जब तुम्हारा
Yes, sir.
मोनो एटॉमिक की 3/2 kBT आई थी एनर्जी, तो तुमने इसको Na से मल्टीप्लाई करके 3/2 RT लिख लिया था. फिर इसको टेम्परेचर के रेस्पेक्ट में डिफरेंशिएट किया था तो 3/2 R आ गया था. यही तो CV है.
Yes, sir. Yes, sir.
देखो ये चीजें जो पहले जो सिंपल बातें बताई जा रही हैं उसको आपको साथ लेके चलना होगा. आप ऐसे नहीं कर सकते कि जो बेसिक बात बताई गई उसको जस्ट यू कैन लीव इट. शिवेश,
Yes, sir.
बेसिक जो रिवीजन है दैट यू हैव टू डू. ओके,
Yes, sir.
ये मैंने नहीं बताया है कि स्पेसिफिक हीट कैसे निकालते हैं.
Yes, sir. बताया था सर.
तो आपको रिवाइज करना है, वो आपकी रिस्पॉन्सिबिलिटी है. इन चीजों पे मैं इसलिए आपको प्रेशराइज करता हूं बिकॉज अगर ये एटीट्यूड रहेगा तो आप कैसे सारी चीजों को याद रखोगे. when things are going step by step, you have to take care of all those things. रिवाइज करना सारा पुराना. ओके, एनी अदर थिंग बताओ शिवेश.
No, sir. Clear हो गया सर.
अब मैं आपसे कह रहा हूं कि एक HCN मॉलिक्यूल है, HCN, इस टाइप का मॉलिक्यूल है, HCN मॉलिक्यूल. ओके, वी आर नॉट राइटिंग मेकिंग बॉन्ड्स एंड ऑल, कैसे बॉन्ड है, डबल बॉन्ड, ट्रिपल बॉन्ड, आई डोंट नो. ओके, but it is a linear molecule like this, and in question they are giving all modes are excited. All modes are excited. First of all, let us do it step by step. A, one mode excited, one vibrational mode is excited. चलो बताओ शिवेश, एनर्जी कैसे लिखूं? एवरेज एनर्जी ऑफ वन मॉलिक्यूल, हाउ टू राइट? What type of molecule is this?
Linear.
You are Shivesh.
Sir.
शिवेश बताओ किस टाइप का मॉलिक्यूल है, लीनियर है कि नॉन लीनियर है? बस यही फायदा है आपका कैमरे के पीछे. हाँ, म्यूट कर दो, बात खत्म. क्यों? You can't tell that this is linear. Hmm? This is in a straight line. बाकी लोग बताओ भाई, are you understanding this?
Yes.
Yes, sir.
This is a linear. This is a linear molecule. And what I have given you the formula when all modes are excited. So we have only one mode excited. So 3 by 2 kBT plus 2 into 1 by 2 kBT plus one mode excited kBT. Correct?
Yes, sir.
So it will become how much? Three by 2 kBT plus 2 kBT, which is
7 by
7/2 kBT.
7 by 2 kBT, which is how much? 4.5 kBT. What is CV?
3.5.
Sir, 3.5
5.
जरा ढूंढो शिवेश कहाँ गए, पुनीत देखो जरा.
हेलो
हाँ,
सर, नेटवर्क प्रॉब्लम हो गया था सर.
अभी मैं इलाहाबाद पहुंच जाऊंगा.
अरे सॉरी सर, वो नेटवर्क प्रॉब्लम हो गया था सर.
CV बताओ 4.5 kBT है एनर्जी, CV कितना होगा?
4.5 R.
बस समझ गया।
3.5 sir.
3.5
Four-
sir.
0.5 is
2 3 जा 6.
अरे 4.5 kBT ही आया है ना?
7/2 sir. 3.5.
ओह सॉरी 3.5
इस
आया है ना?
ये क्या आ रहा है?
शिवेश अपना माइक ऑफ कर लो।
हम्म,
3.5 R बोल दो यार जरा, माइक ऑफ कर लो।
Okay sir.
3.5 R and CP what is CP?
TV plus R.
4.5 R.
Yes sir.
yes
So please remember, sometimes they ask CP and you are so happy to get CV, so immediately you take CV. Okay? This happened in JEST exam. They asked CP and some students just got CV and that was in the option. You have to be very, very careful. Write it here. That we have to see whether they have a CP or CV. All right? And B, if all modes are excited, what is average energy? N वाला formula बताओ. 3
3n minus 5/2.
minus 5/2 kBT, which is
6.
9, 18, 13, 6.5 kBT.
yes sir
So CV 6.5 R and CP 7.5 R. Correct?
Yes sir.
Is that okay?
yes sir
So this concept is clear?
Yes, sir.
Okay. Can I erase this?
Yes sir.
Okay. Now we have developed a concept and it looks so easy that now I can understand the molecular specific heat. But it is not that easy. Let me tell you, the concept of degree of freedom is very, very complicated because it is at molecular level. And what modes are excited? It is not an easy concept because molecules are there. Sometimes, like if you see in chemistry, molecules are like doing this mode. Huh? You have seen sometimes the figure.
Yes sir.
So go on the Wikipedia page sometimes and see the figure of degree of freedom. So so if molecule is doing like this, it is a different mode. And if there is a phase difference, I mean, it is going like this and this and this and this. So it is considered to be different modes. So actually it is at quantum mechanical level because it is a matter of molecule. The atoms are involved, electrons are involved, their bonds are involved. So it is molecular quantum mechanics that get involved into it. And जिसको मैं कह रहा हूँ कि moment of inertia zero होगा along the line. So sometimes the molecules, when they oscillate like this, they wobble because they don't follow the straight line. Some heavy molecules, so they wobble like this. So that also increases the degree of freedom and the contribution to the energy. So that's why I'm saying that actual calculation of degree of freedom and to correlate it to experimental result goes way forward to quantum mechanics, where the molecular quantum mechanics is involved, and then we understand the real degree of freedom and hence gamma, the adiabatic exponent, and hence all type of molecular properties, specific heats, etc., thermal properties. So this is a drawback that to make kinetic theory of gases, which we have discussed up to a level where we understand all kind of properties, involves a very higher physics that is called quantum mechanics. Okay, but up to certain level, especially at less temperatures, uh, it works quite a well. So like Newtonian mechanics, it works for most of the things, but at atomic level, molecular level, at the level of electrons, or at very higher speeds, so in those situations it fails. Otherwise it works well. So the same situation is with this also. Okay, now I told you that there is a distribution of velocity, so that I have to discuss. So I told you that there is a distribution of velocity. Like for example, I told you that all kind of velocity, all kind of speed exists. Suppose I take the magnitude of velocity. So if there are, say, n molecules, let me take it 10 molecules. If there are 10 molecules, so they will belong to different speeds. And if I increase the number to million, there will be different molecules n1, n2, n3, n4, dash dash dash, total n, having different speeds like 0, v1, v2, and very large speeds like infinity. So this is what is called distribution. इसको क्या कहते हैं? This is called the distribution. So this distribution now have to, so actually I have to now understand the probability distribution of the molecules. I have to understand the probability distribution of the molecules. Okay? So I at any stretch I will then take 1 hour to discuss density of states first. Density of states. And then we will enter into Maxwell-Boltzmann distribution. Density of states and Maxwell-Boltzmann distribution. ठीक है भाई?
Yes, sir.
Yes, sir.
तो अच्छे से सब लोगों को रिवाइज कर लेना है, बिकॉज जो चीजें पीछे आती रहेंगी वो सारी बहुत जल्दी जल्दी यूज होने वाली है. सो वॉट एवर आई हैव टॉट is very important. Revise each and every line, and that will be used. Like I did the SCN question that was asked in TIFR. So without telling you, I include all type of questions from all good books, all previous year questions many times, which are insightful. Those which are simple, that I leave it for you. But those which are insightful, I discuss in class. Okay? ठीक है भाई? और फिर मैं रुकता हूँ. और जो वेक्टर वाला एक क्लास बचा हुआ है वो मैं किसी और दिन लूंगा, आज नहीं लूंगा. ठीक है ना?
Okay, sir.
ओके,
Yes, sir.
थैंक यू. थैंक यू.
Thank you, sir. Good night.
Thank you, sir.
Thank you, sir.
थैंक यू.
Thank you.